In this video, we'll be looking at the derivatives of inverse trig functions. Notice that the difference between some of these are very similar, so we have to be careful. The derivative of inverse sine and inverse cosine are very, very similar. The only difference is inverse cosine has a negative out front. Same thing with the inverse cosecant and inverse secant. The only difference is inverse cosecant has a negative out front. And similarly, inverse tangent and inverse cotangent, again, one of these, inverse cotangent, has a negative out front. They're very easy to confuse, so be careful when using them. For example, y equals inverse cosine of e to the 2x. First, recognize which formula we need to be using. Inverse cosine. The next thing you want to note is in the formula, the argument on inverse cosine is x, and then the variable in the formula is also x. But look at the argument on our actual example, it's e to the 2x. It's not simply x. Just remember that when we use the formula. So dy dx is, using the formula, negative 1 over the square root of 1 minus, instead of writing just x, we're going to replace that x with the argument e to the 2x. And don't forget that that is squared. And since the argument was not simply x, we need to use the chain rule and multiply by the derivative of the argument. The derivative of e to the 2x is e to the 2x, chain rule again, multiplied by 2. So now simplifying this, we get 2 e to the 2x over the square root of 1 minus e to the 4x. This time we're trying to find the derivative of arcsine. First, recognize which formula we need to use, and then we can start finding dy dx. We have 1 over the square root of 1 minus the argument, 3x plus 1 squared. And since the argument on the arcsine function was not simply x, we need to use the chain rule and multiply by the derivative of the argument, which is 3. Simplifying a little bit, we can put the 3 in the numerator, and in the denominator we can FOIL the binomial. Next, we will distribute the negative sign and combine like terms. The ones cancel, and we have dy dx.